Hi, everybody. Look at that. Everything is working. Working as intended. Which, right now, to me, that feels like amazing. Oh, and then also there's a cat. This is Maya. Let's see if we can get her to say hi. Hi. Say hi. Say hi on the mic. There you go. That's Maya. Maya loves my class. Seriously, if we were, like, doing class at the college, she would probably want to come to class. Because that is the kind of weird cat that she is. Oh, and she immediately left because I called her weird, I guess. Where are we leaving off today? Let's see. Yesterday we did addition with Sigfigs, so I hope that you have had some time to look over those rules and do some practice problems. Because what we're going to do now is we're going to do the multiplication rules, which are totally different. Have nothing to do with the addition rules, and I do want you to keep them separate. So it's sort of helpful that we had a day to separate these two rules. That's just where the lecture fell. But very important when we go to the next section, don't apply anything of what you learned yesterday to what we're doing today, and don't apply anything of what you're learning today to what we did yesterday, because you're going to have to start doing both operations at once. And it's going to feel kind of awkward. And now there's the other cat who is on the floor. Hi. Hi, Kresnik. What are you pawing at? He's just, like, sat in the middle of the floor and started yowling. Oh my goodness. I like, turned around for, like, a third of a second, and when I turned back, he was gone. My cats are weird. Oh, one thing I do want to mention before we actually start with the lecture. Two things, actually. First is I assigned quiz number 1, so that is now available on Canvas. You can find that in the quizzes tab or the assignments tab. They go to the same place, specifically for quizzes. Make sure that you do that by the deadline shown on the screen. That is Monday, the 17th of January. Do note that quizzes have a 24-hour closing time after the deadline. So I set the deadline a day early before it closes, just because when I set the closing date on the deadline, everybody asked me for an extension. And I was like, well, okay, yeah, whatever. And so I just automatically give you 24 more hours in case you need it. So yeah. And then later today, after we finish chapter 2, we're going to talk a little bit about lab worksheet number 1, which will be due next week, and then I'll also add it down at the bottom. It would be funny if you named your cats after elements. Oh man, I love chemistry, but like I don't want anything to do with chemistry in my life, so I'm not going to name any cats after like constants or stuff. I named my cats, and this is true, after video game monsters. So if you've played Shin Megami Tensei, Maya and Kresnik are monsters in that. And when I say monsters, what I actually mean are like mythological creatures that things are based off of. And the reason I named them Maya and Kresnik was they had previous names that were similar. I want to say it was like Mara and Keshik. And I was like, I want to make it my own, so I just changed it slightly. Because these two cats are adopted from a friend. So, alright, that's enough about my cats. Let's do some math. On the screen is a math problem that everybody can do. You just put it in your calculator, you type in those numbers, you type the X button between them, right? To multiply them together. That is easy enough to do. Now, let's consider this if you were going to do this long ways, sort of like how we did math before, right? So here's our long ways setup. And what I have done is I have added in enough question marks so that I have the same number of digits for both numbers. So if I was going to multiply here, oops, that's not the button that I meant to hit. If I was going to multiply here, 5 times question mark would be question mark. Actually, this whole first row would just be a bunch of question marks, because I'm multiplying by the first digit. Then the second digit, when I start down here, same thing, right? It's just completely worthless. And then I have another one of those right there. And it's not until I get to the fourth digit where I'm actually going to start getting numbers. So 5 times 4 is 20, carry the 2. 8 times 6 is 48, plus 2 is... Oh, I'm multiplying by the wrong number, sorry. 8 times 4 is 32. 2 is 34. 9 times 4 is 36, 39, and so on and so forth, right? Nobody wants to do this, right? This is like 4th grade, 3rd grade. Remember when you did long multiplication? Yeah, we're done with that shit, right? Nobody wants to do this. But the point is that when we do long multiplication after all these steps, the last step is addition, right? And if you have all these question marks in here, you're going to get a bunch of blanks in your answer that you don't get to use, right? And so you're only going to be able to use numbers from this point forward. So doing long multiplication and then doing the multiplication in your calculator are going to give two different results in the sense that your calculator just spews out a bunch of numbers, and the long multiplication with sig figs is going to be something that we're going to have to consider. So how the heck do we deal with this? And the answer is, well, somebody has done all the long multiplication for us and come up with an algorithm. And that algorithm is the following. When you do multiplication or division, because division is just multiplying by an inverse, look at the values that you're using. So here are my values, 1 and 2. And count the number of sig figs they have. The first value, 14.2985, has how many sig figs? Very good. You should have said 6. Or maybe you were going to type 6, but I'm like 20 seconds in the future, so this is 6 sig figs. What about the bottom one? And it has 2. Good. So we'll just put that on the screen. Okay, now that we've found the number of sig figs, we're going to do the math, and our answer is going to have the number of sig figs that is the smaller of the two. So what's smaller, 6 or 2? Obviously 2 is, right? So our answer is going to have 2 sig figs, regardless of what the answer is. So now you just go to the calculator. I'm going to punch the numbers in the calculator. 14.29, I already have done that, so. This is what the calculator tells me when I do the multiplication. 91.5104. But because my values have 2 sig figs as my smallest number of where'd my mouse go? Sorry, something flashed at me and I lost the mouse. Because 2 sig figs was the smaller of the number of sig figs, that's how many my answer will have. So I have to round this down to 2 sig figs. Now, you can't just pick any 2 sig figs, because 14 point whatever times 6 point whatever is not going to equal 0.4 if I just take those 2 on the end, right? That doesn't make any sense. Our answer needs to have the appropriate value, because we're still doing math, right? So when you are taking numbers, you want to take them from the left. So I'm going to take the first 2, and I'm going to report that as my answer after doing rounding. And there you go. So multiplication and division, the rules are a little bit simpler. If you have 2 values, pick the one that has fewer sig figs, and that's how many your answer will have. If you have 5 values, pick the one that has the fewest sig figs, and that's how many your answer has. And this will always work, whether you're doing multiplication or division. This is how the rule works. Now, something to notice, we'll go over to this screen for this real quick, is that if you did a problem like, say, this, 129.8384 times 6.3. So would you always round down to the lowest sig fig? We're going to use the rules of rounding here. So if you have 0, if your rounding digit is 5 or higher, rounds up. And if it's 4 or lower, you round down. If you've heard of bankers rounding or round to even, we're not going to do that in this class because that's useful for statistics, but it is too much to be bothered to do here. So, yeah, no problem. All right, I'm going to punch these numbers in my calculator. And we're going to do this example. 1.9, 129, oops, sorry, I have extra shit in my calculator. 0.8384 times 6.3. Why is the 6.3 all the way to the right? Because I'm just multiplying. If we're adding, I'd have to line up the decimal points. I only did that in the last example because I wanted to have those question marks in there to show that they have some impact on your result. So when I do this on the calculator, I get 817.98192. And so now let's consider sig figs. So how many sig figs does this top number have? And I'll actually ask you to type that in the chat. How many sig figs does each number have? The top number and the bottom number I multiplied by. Good. The top number is 7 sig figs, which I'm going to abbreviate as SF, San Francisco. And the bottom number has 2 sig figs. So our answer should have 2 sig figs because we want to have the smallest, yeah? So I'm going to round to 2 sig figs. So I'm going to take these two, and this is going to be my answer, right? Well, wait a second. Hold on. That doesn't make any sense, yeah? So if I take sig figs, and then the value or magnitude of my answer changes, I have an issue, don't I? 129 times 6 is not 82. I'm multiplying. I should get a number bigger than 129. So I certainly can't get a number smaller than 129, right? But I have 2 sig figs already. What do? Well, you got to put placeholders in, right? So remember that placeholders are not sig figs. And you may have to add placeholders to get the correct magnitude, right? 817 rounded to the tens place is 820, and that checks out. What it is not is 82. 82 is not how you round 817 to the tens place, okay? So be careful when you do rounding with to an appropriate number of sig figs, because it's very easy for people to just follow the rules sort of blindly, and then you get to this part where you're like, oh, I have to add a 0? Yeah, you do, because you want the magnitude of the answer to be relatively the same after you're done rounding it, right? Likewise, if you have to add digits for sig figs for a decimal, so like let's say that you do a multiplication problem, and the result that your calculator prints is this. But your answer is supposed to have 4 sig figs in it, right? If that's the case, then you do have to do that, because these zeros are significant due to the decimal rule. Okay, so only add in extra zeros if you intend to, because you need to put a placeholder for the magnitude, which would be up here, or because you need more sig figs for your answer, and you need to add more zeros for, say, a decimal or something. In a second, we're going to talk about scientific notation, which is another way to always get the correct number of sig figs. What if the last number of the sig fig is 0 and you have to add a placeholder? So that would be a situation like this, where you need to have 2 sig figs, and your number was like 800. What do I do here? Because these are supposed to be significant, but this one's not. How do I do that? And the answer is what I was just segueing to, is just scientific notation. And we'll get to that in a second here, but this is what that would look like. That would have 2 sig figs. And we're going to do that in the next section here. So, just jumping ahead. All right. So let's now do some practice exercises here. So I didn't want to just put the answer on the screen there. So what I want you to do is I want you to do this multiplication. You can assign the number of sig figs and then just punch in your calculator. You don't need to do this long ways. Use your calculator for this one. And I want you to enter the correct answer with the correct number of sig figs in the chat. Okay? I'll give you 2 minutes to try it. We'll go over the answer in just a moment. All right. So let's punch this in the calculator. So when I do this, 5.4336 times 1.2, the number I get is 6.52032. How many significant figures should my answer have? Well, this first value here has 5 sig figs. This one right here has 2 sig figs. So my answer should have 2 sig figs, because this is the smaller of the two. All right, so now we're going to round, and we're going to take the first 2 sig figs, so we're going to round to this spot. So I get 6.5 as my answer. All right, we need more practice. Here you go. I want you to do this division problem. It's the same as multiplication, except you hit the dividing button instead of the multiplying button. So try this problem. Type in the correct number of sig figs in your answer. Is multiplication much easier than adding, subtracting sig figs? Yes, the rules are unique. And multiplication division is a lot easier. Resist the temptation, however, to just do this to everything. Why wouldn't you round to 7? Because we are rounding to the 10th place. Because we get to keep 2 sig figs, right? We are considering the rule of rounding. We are rounding to this spot, and the next number that we are rounding, the 2, is lower than 5, so we round down to 6.5. You do not round to the decimal place. Otherwise, every number less than 1 would be round down to 0, right? You have 0.084415 rounds to 0, right? Everything would just be 0. You round to wherever your sig figs dictate. So be careful. Try this next one. I'll give you another minute. The 0 on the right of 0.380 is not a placeholder. That is a sig fig, because remember the decimal rule. Oh, hi. I have another cat here. This is Kresnik. I don't know if you can hear him. Kresnik, say hi. Meow. My cats are being social today, I guess. Remember the decimal rule. So here's my decimal. Here are my sig figs. All numbers to the right of those are also sig figs. That last 0 on 380 is significant. Yes, that's correct. We're going to punch this into the calculator. And my calculator gave me this answer. If I can click on this thing and it'll work. There we go. So this is the result that the calculator gave me. 91.673.68421. That's way too many sig figs, isn't it? So let's go count sig figs. Let me get a different color out. So this is 5 sig figs. These are my sig figs in this one. There are 3. Because again, decimal rule. So make sure you apply the decimal rule anytime you see the decimal. So my answer should have 3 sig figs. So I'm going to take the first 3 numbers. Doot, doot, doot. We're going to round right there. And then the next digit is 7, so we'll round up. So the answer I would report would be 91.7, which most people got. Very good. All right, last problem that we're going to do. I'm going to have to clear the text for this real quick. Do this operation, and yes, you're going to get a weird answer because of sig figs. So what is 7.63829 divided by 2? Punch your answer in the chat. Once you got it, it'll give you a minute and a half to do it. All right, so I'm going to punch it in the calculator, just like we've been doing for all these. 7.63829 over 2. And this is what my calculator printed out for me. 3.819145. How many significant figures should my answer have? It looks like everybody's writing a 1-digit number, and that's correct, because this 2 only has 1 sig fig, right? This has 6 sig figs. So because this is the smaller number of sig figs, my answer must only have 1 sig fig. So we're going to round it right there. And the next digit that I round to rounds up. So this is the answer I report, is 4. And yeah, that's kind of frustrating, right? Like, you lose all those digits? Yeah, you totally do if you only have 1 sig fig. If you have a really precise measurement and you multiply by a really imprecise measurement, your answer is summarily imprecise. So just be mindful of that. Some other things to be aware of when you are doing these types of calculations is that your calculator does not know what sig figs are, again. So as an example, go ahead and type this in your calculator. And print in the chat what your answer is for that. And I'm going to do this on screen to indicate what the answer should be. So for when you are doing rounding, the decimal point doesn't matter if there's a decimal point or not. You are always rounding to the digit that you indicate as the last sig fig, and then you consider the digit after that for rounding. So, like, if you have... If this is your number and you're rounding to the hundreds place, this is your result because you look at the 7 and round it up. Same thing if you had this number, like that. You do the same thing. So we're just doing the rounding rules for our result after we consider the number of sig figs that we need. Anyway, I hope that you typed in this sum into your calculator. You probably noticed that it just shows you the number 8, and it probably puts a dot there too. Your calculator just puts a decimal point after everything. So be careful. Your calculator does not know what sig figs are. It will do them wrong, and that's no good. So you need to use the rules and algorithms that we have talked about yesterday and today when doing significant figures, and you're going to apply these to every calculation you do in this class and the sciences, okay? This is not a curiosity. This is not just like, oh, that's cool. I learned about sig figs. Now I'm going to go back to doing math how I used to. No, you will never do math the way you used to ever again. Just let that sink in there for a second. You're going to use sig figs for math for the rest of your existence. This is how math is done in the sciences and in the medical health profession. So just keep that in mind. How do I do a problem when I have both operations? Cries in sig fig. Yeah, if this is rough, it only gets worse from here, so I don't know what to tell you. What do I do when I have both operations? You cannot just punch this in the calculator and use whatever rules you want to use. That's not an option. That's not a rule that we went over. There's no use whatever the fuck you please rule, right? So, how do we do this? And here's what we have to do. So the first thing we have to do is we have to use order of operations. Do we all remember the order of operations? Oops, what did I just do? I clicked the wrong thing. Do we remember our PEMDAS? Where P is parentheses, E is exponent, multiplication, division, addition, subtraction. Where we... What was this? Please excuse my dumb ass sibling. We all remember this, right? I seem to remember something about like Aunt Sally or whatever. I never had an Aunt Sally. I definitely had a dumbass sibling. My brother was a piece of shit. So, this is how I learned it. No, I totally made this up for this class, but anyway. This is the order of operations. So we start at the top and we work downward. And we do these first, and then we do these last. So, let's do the order of operations on this problem. So up at the top, you'll see that there are parentheses. Oops, I should leave this on the screen because we're going to need it. So, for that operation, 73.8 minus 70.983 over 2.639. My parentheses will be done first. So I do what's in the parentheses regardless of where it falls on PEMDAS, right? So I'm going to do everything in the parentheses first. So I'm going to do that subtraction first, which means I have to do this. All right. These are what we did yesterday. We did subtraction yesterday. What were the rules for subtraction? We care about working from place to place and finding the first place that has sig figs in it. So if I start here, I have a blank in this spot, so I cannot use this number. If I go to the next position, same deal, can't use it because there's no number there. But if I start here, this will work. So I'm going to round my answer to this position. And I drew over the decimal points. I didn't mean to do that. So let's type this in the calculator. 73.8 minus 70.983. We'll just type in the whole thing. And the calculator says 2.817. So 2.817. I don't get to keep the 1 and the 7. So I'm going to round my result to 2.8. So now that I've done this, the result of the parentheses is 2.8. And so my problem now looks like this. So now what do I do? Well, there's only division left to do, so I'm going to do the division, and I'm going to use sig figs to do it. How many significant figures should my answer have for a division problem? Well, now that it's division, it's going to depend on the values that are put in here. So this is 2 sig figs, and this is 4 sig figs. So my answer should have 2 sig figs. So I'm going to type 2.8 over 2.639 in the calculator. This is what the calculator tells me. But I only want 2 sig figs, right? So I'm going to keep the first and round to that position. And the answer I get is 1.1. It is not 2.9. It is 2.8 because 2.817 rounds to 2.8. Because remember, you do have to use these digits here in your subtraction. Because those are known, and they do influence your result to some degree. So you don't just get to truncate away all of your numbers. Do the subtraction like we normally would do subtraction, treating the blanks as 0, but then use the blanks to apply sig figs. So be careful. All right, so we'll go back to here, and then my slides will walk you through that. So if we do the subtraction rules first, you get this. If you do the division rules next, you get that. Now, something that you will notice, and this is a mistake that some people will make, I guarantee it. Because the multiplication and division rules are easy, everybody wants to go, oh, okay, well, I'm just going to count sig figs up here. So I got 3 and 5 and 4. So my answer should have 3. And guess what? You'll get it wrong. 2.9 is not the answer. I can assure you of that because I did this problem yesterday, and a student thought it was 2.9, and I was like, oh, it's 2.9. And I was like, how could this be wrong after like 15 years of having this slide? And then we did the problem again a third time, and it was not 2.9. So what you have done, if you were getting 2.9, is you're doing this. For this math up here, what you're saying is, oh, these are not used in my answer, so I'm just going to get rid of these, and then 18 minus 9 is 9. Do not do that. Type this whole thing in your calculator. 73.8 minus 70.983 equals 2.817. Then you round. So be careful. Don't throw away known digits until you are required to. All right, let's have you do some practice. Here you go. So I have a bunch of problems on the board. I'm going to give you like 5 or 6 minutes to do as many of these as you can, and we'll go over the answers. Do the following calculations to the correct number of significant figures, and also use the correct rules as required. So the first like 5 or 6 or so, you only have to do one operation. So multiplication, division, or addition, subtraction. The last two problems that you have to do both. Make sure that you apply the rules correctly and do the operations in the parentheses first, because that will affect your result, okay? I'm going to number them for you, or we'll letter them. A, B, C, D, E, F, G. There you go. And so you can say A is or whatever, and then go ahead and do that. All right, so I'm going to give you about 5 or 6 minutes to do this, and I will check in with you after that, and I'll answer any questions you have in the chat. So good luck. We're all counting on you. We'll do a few more minutes here. When you get your answers, go ahead and type them in the chat so I know roughly where you're at. All right, one more minute and we'll go over the answers. All right, let's go over the answers here, and then we'll take our break. So let's go on to this screen. Oops, that's not quite right. And we'll just put 3 at a time there. That looks good. My cat was here during the break, demanding attention, and as soon as I started talking to you guys, she got jealous and ran away. So where'd my pen go? There it is. So for problem A, I just type those into the calculator. And when I do that, I get this for my result. Now, how many significant figures should each value have? So this first one here has 2 sig figs. That's those 2. The next one has 4 sig figs. I'm doing multiplication, so I want the smaller number of sig figs. So I need to take 2 sig figs. These are not sig figs. These are placeholders. I need to take this 4 and this 0 right here. And then I'm going to round up because the next digit is 6. So 0.041 is the correct answer. For B, we're going to do something similar, except we're going to do division. So when I punch or type that in there, I combined both words in my head for some reason. I get, this is my answer, 2.0295 is what my calculator says. That's way too many digits, though, right? So 4 sig figs for the top number because they're all significant. 2 sig figs for the bottom number. This is the smaller one, so I'm going to keep 2. And then the next digit I round to rounds down. I get 2.0 as my answer. For problem C, it's an addition. An addition I have to do vertically. And remember that addition goes to places. What place coming from the right is the first place that has a significant figure in every number. And so if I start here, well, this is no good because these are blank. Those aren't sig figs. Same thing here. And same thing here. When I get to the ones place, though, this is not a sig fig. This is a placeholder. In fact, none of these are sig figs. They're all placeholders. This is the first number that I get to where there's a known number in each of these. These are known to be 0, right? So when I get my answer here, and I round to the thousands place, that's the answer I report, is 3,000. So don't fall for those tricks. Make sure that you are following the addition rules correctly. Placeholders are not sig figs. Where'd my mouse go? There it is. All right, I gotta scroll down a little bit. So D here. D is a subtraction. I don't really need to do this one on a calculator. You could. This is what I get for D. Now I have to check for sig figs here. I look at the first digit. This is a sig fig. This is a sig fig. So I can round to this position, even though I have fewer sig figs, right? This is the correct answer. What is not the correct answer, I'm going to do this, is to write this. Why is this answer wrong? How is 3 minus 6 equals 7? It's 13 minus 6 equals 7 because we're borrowing. I mean, do I have to do this? I sense that we may have to brush up on our algebra. So definitely make sure you do that. But back to the point at hand, do not do this. Don't do this. And the reason that this is wrong is because in subtraction, we don't care about the number of sig figs. Don't go, oh, it has 3 sig figs and it has 3 sig figs. So my answer should too. No, that's not the addition rules. Those are the multiplication rules. Subtraction only cares about this place. Okay? We don't care about the number of sig figs in addition or subtraction. We care about places, right? And my answer would round to the hundredths place, which is this place right here. Okay? Be very careful, because that is a super common mistake. Everybody's just like counting sig figs, and they're like, oh, I don't think I have enough. I'll just tack on some zeros for the subtraction problem. And that is going to haunt you in one of the labs later on. So be careful. All right, let's look at E. Now, if you type this in your calculator, this is what happens. And it turns out this is wrong. The answer is not 12. Because this is 4 sig figs, and this is 4 sig figs, due to the decimal rule. So my answer should also have 4 sig figs. So I need to do that. And that's the answer. Now, you might look at that and go, well, wait a second, the first ones have 3 decimal places, and the second one has 3 decimal places. Why doesn't my third answer? Because those are the rules for addition, and this is a multiplication problem. I'm picking these problems very specifically for this purpose. Don't mix up the rules, because it's very easy to do. And this is why I have given you like 50 practice problems in the textbook to do these with. All right. F and G are mixed problems, so we have to apply both sets of rules. So for problem F, we're going to do the addition first. So let's set that up vertically. So if I do my addition here, and then I check for where I'm going to round my answer to, these places don't work. This one's good, though. So my addition rounds to the 10th place, because that's the first spot where I see a sig fig in each value. So this is the result that I would get for the addition part. And now I have to take that number and multiply it by 0.00390. And according to the calculator, when I do that, I get 0.16224. And now we'll do the multiplication rules for sig figs. This has 3 sig figs. These are my my significant figures for this value. So my answer should have 3 sig figs, and I will take these 3 right here. Very good. Oh, we're not done. We have to do G also. Now, don't worry if I'm going too fast. You can always pause the video. Remember that. You can play it back as many times as you want. How many zeros do I have on the end here? 3. Okay. All right, so here's our problem. I'm going to do the division first. And when I punch this in the calculator, 52.5000 divided by 3.6, I get 14.583333 forever. How many significant figures should I report? Well, this first number, these are all significant, so this is 6. This is 2 sig figs. This is the smaller of the two, since I'm doing division. So my result here needs to have 2 sig figs. So this should have 2 sig figs. And I'm going to pick those 2. And there's my answer for the division part, 15. So now this problem looks like this. 15, which I reported, minus 11, which if we set it up vertically, looks like this. And I can round to the ones place because I have a digit in the ones for both of those. This is the answer you report. All right. That is a selection of exercises for significant figures. Very, very important that you practice these because we're never going to not use significant figures in addition and subtraction and multiplication and division. You're going to be doing a lot of math in this class, whether you want to or not. I'm going to drag you to it kicking and screaming. But for now, what I'm going to make you do is take a break. So we're going to convene in about 10 minutes here. I'll get the Paradise Killer music back up. And I will see you in a bit. So... Hi, everybody. Welcome back from the break. Regarding the name of the textbook, it is in the syllabus. You can grab all that information from the syllabus, so you can find the textbook. The ISBN is in there too. Should all be available. All right, so we're going to move on to the next section, which is scientific notation. We're going to do this pretty quickly because scientific notation is kind of a trivial thing that most people are probably familiar with because you have taken Math 96. Is it Math 96 now? Yeah. Or Math 86, anyway. We know how to write numbers in scientific notation. If you move the decimal point to the left, we can write a times 10 to the exponent that increases. So, like, if I do this, and I move this to the left 13 places, I could write my answer like this. So, there should be, in this space right here, 13 places. And that's where this number comes from. Now, this right here, this says 1 decimal place, but you can set this to, so this can be as many as you need. So if you need more significant figures, you can put extra digits back there. So if I wanted to write 1 or 10 trillion with 3 sig figs, I could then do this. 1.00 times 10 to the 13. This would be okay. This would have 3 significant figures. So scientific notation gives us the ability to write as many sig figs as we need to for any number. And that's helpful. All right, for the next one, we'll look at small numbers. So if I look at the diameter of this person's hair, I have no idea who this is. I just grabbed this random picture off the internet years and years ago. And I moved the decimal point to the right, so I'm going to move it to the right 5 places here, which means this decreases by 5. So from here to there, we went 5 places. That's where the 5 comes from. So a negative exponent represents a small number that we're moving the decimal point over to make a bigger number. And to counteract that bigness, we have to multiply it by 10 to the minus something. And again, you can have any number of significant figures that you need on scientific notation. Just add or remove them as necessary to accommodate your answer. Now, I'm not saying you can have as many as you need to just like bypass all the rules. What I'm saying is, if you're trying to write something in scientific notation and your answer requires 4 sig figs, you can add extra zeros to your scientific notation if you need to get to 4. Or you can drop numbers, or whatever you need to do so that it matches with the requirements of your answer. So there's our summary. Big numbers, the decimal place goes left. Your exponent increases. Small numbers, the decimal place goes to the right, and your exponent decreases. That should be pretty straightforward. Now, typing these into the chat is kind of impossible in scientific notation, but do the best that you can. So, for example, if you wanted to type like 5.0 times 10 to the 4, I typed 5 on accident. You could do something like that to indicate your answer, but I'll letter these out. So here we got A, oops, B, and C. Go ahead and type the answers to these in scientific notation in the chat, and we'll go over the answers in just a moment. All right, one more minute. We'll go over the answers here. All right, let's go over the answers here. So, oh, Maya's here to go over the answers. Say hi, Maya. She just wants to bump her nose against my elbow, I guess. I don't know. All right, so I put these little spaces every 3 to make it easier to count for myself. So 3, 6, 9, 12. So this should be 4.48794 times 10 to the 12. I'm just chopping off all the rest of the zeros. Now, I didn't ask to put this in any number of sig figs, but you could remove or add zeros. You could add zeros at the end or remove some of these digits as necessary. So, for example, if I wanted to only have 3 sig figs, I would do this. 4.4. I'd round the 8. The digit after the 8 is a 7, so that rounds up. Times 10 to the 12. So, for example, if you had to do 3 sig figs, that's what you would do. For B, 3, 6, 9, 12, 13, 14. 3.61 times 10 to the 14. There you go. And then finally, for C, we're going to go the opposite direction. 3, 6, 9, 10, 11. 3.1 times 10 to the minus 11. And then these are technically measurements, so I should put the units on there. There we go. Hi. Hi, I'm teaching. Hi. She really wants me to hold her. So why did we stop at 4.48794? I just stopped when I started hitting all the zeros. Because those numbers as written, those zeros are placeholders. Because there's no decimal point. Any questions, let me know. I'm just petting a cat. Maya, say hi. Maya. 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 Now she doesn't want to talk anymore. All right. So the next sections in Chapter 2, and we're not going to finish this today because we only have about 30 more minutes or so. What we're going to be doing is we're going to be doing calculations to do conversions. And we're going to do a bunch of problems that are going to seem kind of silly. Do we usually put the decimal point after the first number? Yes. So in scientific notation, your decimal point always has one number in front of it, then the decimal, then however many decimal places after you want to include. Now, does it have to? Not necessarily, but the convention is that this is what we do. And so almost all scientific notation numbers that you'll run into will be written this way. There are some exceptions in like engineering, but we're not going to go into those types of examples. Are we, Maya? This is where I wish I had a webcam, so I could just point it at the cat. All right, so this next section, we're going to start looking at different units and trying converting between them. At the beginning of this set of slides, in one of the videos that I posted, I showed you a bunch of tables like this. And I said that it would be important for you to know these metric prefixes, Not memorize them because, again, this is an online class, but you should be familiar with what these metric prefixes are, because now what we're going to do is we're going to convert between them. So, like, if I have some number of centimeters and I want to figure out how many meters that is, or how many millimeters that is, we can do that. We're going to do that in this section. All right. I know that this is true because we have defined it, and it's on our little chart that, again, that I just showed you, right? Oops, my mouse isn't. Oh, that's what's going on. I have the pen on the tablet. Right here. So here's my relationship. Kilo is 10 to the 3. So if a kilogram is 10 to the 3 grams, we could write that as a relationship like this. And what we're going to do is we're going to derive a sort of algebraic expression from this equality. So I'm going to write that down. We're going to put it right here on the left. And I'm going to write it times 10 to the 3 just because it's less things for me to write. And we're going to do a little bit of math. So bear with me. I'm going to prove something. We're going to do this. I'm going to divide both sides by 1 kilogram. Now, what happens if you divide something by itself? What do you get? What is anything divided by itself? What does that equal? Type it in the chat. No, that's 1 multiplied, or that's a number multiplied by 1. I want a number divided by itself. What does that equal? 5 divided by 5 is not 5, right? 1, very good. So, 1 divided by 1 is just 1, but this is true for literally anything, including units. Kilogram divided by kilogram is 1, right? So what I get is, if I reduce this expression, is 1 equals this thing. Now, that's sort of a curiosity, but we're going to come back to that. I'm going to do the same thing over here, except this time I'm going to divide by this number. And like we said, a number divided by itself is 1. But that's true for anything divided by itself. We call that they cancel out, right? And so now I get 1 equals this thing. Now, if I have something equals 1 and something else equals 1, what must be true about those two somethings? Well, they must equal each other, right? And so we have created this relationship. In other words, what I did was I took that equation at the top that is written horizontally, and I created conversion factors that are vertical. And so, in other words, if this is the equality that I was looking at from a line in the textbook, I can set this up in a sort of ratio however I want. I could put this on the top or the bottom, and then the other number goes in the other position. In other words, when we are doing dimensional analysis and are using these relationships off of these tables, such as 1 kilogram is 1,000 grams, we can just flip them upside down however we need to, because they are equal to each other, and they also equal 1. So if I multiply something by a conversion factor, It's not going to change its value. It's going to have the same value, just a different unit at the end of the day. Now, that's the logic behind doing dimensional analysis. What exactly are we trying to do here? Well, I'm just going to skip this forward here. There we go. There's our relationships that we made. What we can now do is we can do things like this. I want to figure out the mass of an object in grams, but I only know its mass in kilograms. So what I can do is I can say, okay, I'm going to multiply by my conversion factor. Now, if I do this, this is the same as me writing it out like this, right? And again, anything divided by itself equals 1. So we could go boop, boop, and cancel those units out because they equal 1. So 5 times 1 times 1,000 grams would give us 5,000 grams, which would be the answer that we are looking for. And so there's that in action. So this is what we're going to be doing. You may have done this in Math 86 or Math 96 already, where you do dimensional analysis and you cancel out units to give you the units that you want. All right, so let's do an example. I have a bowling ball that weighs 6.8 kilograms. I want to know its weight in grams. Oh, that lined up exactly. Look at that. Okay. Where? Oh, my pen was too close to the tablet again. All right, so I have a 6.8 kilogram ball. And I know that for every kilogram I have, that is 1,000 grams, or 10 to the 3. So what I need to do is I need to set up a relationship that will result in my answer being grams. How do I do that? Well, I want to use this relationship in some way so that I get rid of the thing that I don't want and I leave behind the thing that I do. This is called dimensional analysis. How do you get rid of units? Well, I got to put a matching unit down here so it cancels out, right? So in other words, what unit should go down there? Well, it's got to be this kilogram, right? So if I put kilograms down here, and then I'll put the other unit on the other side, these would then cancel, and I would be left with grams. So that's how the units work out. Now we just have to put in these numbers. Well, I have 1 kilogram, so I'm going to find kilogram and put the 1 next to it. I have 1,000 grams, so I'm going to find the grams and put 1,000 next to it. And then finally, I type it in the calculator and do the equation. 6.8 times 10 to the third, or 1,000, divided by 1 is 6,800. So a bowling ball with mass 6.8 kilograms would weigh 6,800 grams. All right. These types of problems are going to be all about setting up the units so that the ones you don't want cancel. The ones that you do want should be what are left over. We're going to have to do that over and over and over again. That's going to be our exercise here. All right, let's do another one. How much does the bowling ball weigh in milligrams? Well, we know it's mass in grams, so we can use that in our answer. So let's write that down. But we need a relationship that relates grams to milligrams because that's what the problem is asking us to do. We need something in milligrams. So according to the table that we had way back here at the start of the slides, oops, hold on. Here's our relationship for milligrams right here. 1 milligram is 10 to the minus 3 grams. I gotta find the slide we were on. There it is. So we can write that down. 1 milligram is equal to 10 to the minus 3 grams. Now, could you write 1,000 milligrams in a gram? You could, but then that chart that you have all those numbers on doesn't really make much sense for just specifically milligrams. So I would recommend that you remember the numbers on the chart and think of 1 milligram is a tiny number of grams, as opposed to there are a lot of milligrams in a gram. That will just help you keep the numbers organized from that chart. All right, now with this information in mind, what I have on the screen here, I want you to try to tell me the number of milligrams that the bowling ball weighs. Okay? So use this information and do a process similar to what I just did above to solve the problem. I'm going to let you tussle with it for about 3 minutes, and then we'll go over the answer together. Okay? I'll see you in a bit. All right, let's go over the answer here. So I have this relationship, 6.8, or I'm sorry, 1 milligram equals 10 to the minus 3 grams. So I need to set up my units first so that I end up with milligrams, because that's what the answer is supposed to be, right? So what unit should go down here in the bottom? It should be this one, right? So if I put grams here and milligrams on top, my grams would cancel out and give me the correct answer. Now I just have to fill in the numbers. Well, I've got 1 milligram, 10 to the minus 3 grams. And then I'm going to take this actually here. I'm just going to move it up there. And so when I punch this into the calculator, what I get is 6800000, or 6.8 times 10 to the 6 milligrams. All right, very good. All right. Now, what my slides are talking about here is that there is no conversion to go directly from kilograms to milligrams, and there is not. So you cannot do this. This is not a conversion that we have on the chart. We only have a conversion that goes through grams. So you do have to do the gram intermediary step each time. So make sure that you do it. So if I gave you 6.8 kilograms, tell me how many milligrams it is, you do have to turn it into grams first, because the relationships that we are using here only exist on this chart. So you might want to have this chart just handy. Like if you have your slides, you can have it printed out, or you could just bookmark it, or whatever. Where are we? We are here. Okay. So now what I want you to do, I want you to do these three problems actually. So the first problem, how many centiliters are in a 2-liter bottle of soda? The thing that's going to get you on the first problem is sig figs. Yeah, there is only one sig fig in your answer because these are all just multiplication, right? Sorry, I like stepped on something and I'm like, what the heck did I step on? I think it's just my foot acting up. For the second problem, I give you the mass of an orc in kilograms, but I want it in milligrams, which means you do have to go through grams. The third problem has a new unit. What the heck is a joule? A joule is a unit of energy. Energy. There we go. The pen didn't work there. But what does that mean in terms of doing the math? It doesn't mean anything new. It is exactly the same. If you got 6.8, then what may have happened is that when you did this calculate, oops, hold on. So when you did this right here, so when you're typing this into your calculator, you're probably typing into something like this: 6,800 times 1 divided by 1 times 10 to the minus 3. Do this part in parentheses. And then see if that works. You should get 6.8 times 10 to the 6. Try that. Going back to this problem here, though, don't worry about what a joule is. Treat this exactly the same. Treat it as if it was like grams. So you have centi something. And I want kilo something. Now, you'll have to go back and look at that chart at the beginning of Unit 2 to get centi to grams. Or centi to regular, for example. Leave you a few minutes to do this, and then we'll go over the answers, and then that'll be it for the day. So I'll see you in a second. All right, I see that some of the answers are coming up in the chat here. Unfortunately, we don't really have time to go over the answers for these 3 problems. So what I'm going to do is I'm going to stop the stream here, and on Monday next week we will begin on this slide and go over the answers immediately. So work on these over the week. Oh, you know what I need to do in these last few minutes real quick? I need to talk about the lab before we go. So let me get that on the screen here real quick. Actually, I guess we'll do it over here. Give me just a second. So lab number 1 does not require much explanation from me because it is basically a homework problem set for what we have done today. So what we will do here is we will go into... I don't need this. This can go away. This, however, could be that. Yeah, okay. All right. Oh, right. This window is huge now because I have a different resolution. Okay. All right. So this is lab worksheet number 1, which I am accessing from the modules tab on Canvas. And there's this big introduction that just basically walks you through everything that we have done in this class so far. Okay, so you don't necessarily need to read over all of that if you don't feel you need to, but if you do feel that you need to and you need more practice, go ahead and look at the examples. Then you're going to get to this thing that says worksheet exercises, and this is what I want you to do. I want you to do these problems all the way up through problem 25. Okay, so these 25 problems are going to require you to type in answers somewhere. And the place that you type those answers in, if you go to the modules tab again, which now you can't see it because my window is resized weird. I'm going to cover the chat again real quick. If you go right here where it says lab worksheet number 1, this is where we were, the lab worksheet number 1 PDF. Clicking on this will give you the Google Sheet for lab number 1, which I'm going to just do this too so that it's in another window here. And this is your answer sheet. So you're going to type in all of your answers in this box. In the first column, you're going to put the number. In the second column, you're going to put the units. And in the third column, you're going to tell me the number of significant figures your answer has. Okay? You're going to just fill that all out. It's 1 point per row. And then I go through and score it when you're done. Now, you can't write in this form directly. What you need to do in order to access this form to have a copy of your own is you need to go File up here, make a copy, and then hit OK. It will save it to your Google Drive. Okay, so once you hit OK, you now have your own version of it that you can type in whatever you want to. Okay, don't write in the do not write in this column section. That is for me. But you could type in all your numbers here. I'm just typing random garbage because this is now a copy of it that lives in my Google Drive. And it says that up here, copy of whatever. Make sure you type your first and last name so I have it. This assignment will be due next week. You have a whole week to do this. And then, of course, you have an extra day after that. We're going to go over more dimensional analysis on Monday. We've done the basics today. And so you have seen enough so that you could do most of the worksheet. But we will do the remainder of the dimensional analysis on Monday for that. So if you start this now and you do everything that you've seen so far, you'll probably be able to do at least half of it. Okay? And if you have any questions about the lab worksheet assignment, let me know. That will appear later tonight for where you turn it in once I have time to do it, because I have to set up for the next class now. So, I do want to thank everybody for coming out to the lecture. Quiz number 1 will be due on Monday the 17th. Make sure that you get that in as soon as you can. If you can't get it in by Monday the 17th, you do have one more day after that to do it. And then lab worksheet number 1 that I just showed on the screen will be due next week. We'll put that due date up a little bit later today. If you have any other questions, let me know. Send me a message over email on Canvas or in the class Discord. Have a great weekend. See you next week.